Good. So this is me. This is me and my talk. And to be honest, I created this talk today morning after 1 year working with Apache Spark almost exclusively just to improve my understanding of Scala. So the reason I started with Spark was it was a few years ago, perhaps 2 or 3 years ago. I needed something that could improve my understanding of Scala. So I started with Kafka first. But at the moment, you may have heard this story before. But this is just quite interesting how my progress into Spark and my understanding of Spark improved over the past year. So just around 1.5 years ago, Kafka decided to move from SBT, my very beloved build tool, to Gradle, which I didn't know much about, but I was very into SBT. So I started looking around for any other project that could improve my Scala skills. So it was right time when I discovered Spark, perhaps because Kafka, Spark, they are pretty similar. Well, not similar, but they are used very often together. So I switched to Spark, and it sparked my interest. It's like this. I just started, reviewing the code, and I saw that there are a lot of opportunities for me to understand Spark, and again contribute to these open source projects. At the time, I was Apache Software Foundation member, so I was part of this Apache Software Foundation community. But the other projects were something I wanted to stop contributing to, because they were mostly about Java EE. So and I really wanted to immerse into Scala, especially into Scala's type system and type level programming, which didn't happen yet. Okay, but it's probably coming. But anyway, Spark is not about how to say. Full-blown Scala programming. It just, Scala is just one among the other 5 languages supported by Spark. So after 1 year, it just hit this 1 year rank. I've got this topic. Why this topic? Because now you should forget about, right this moment, you should forget about RDDs. RDDs are too low level, are just like teaching or learning assembler to understand Scala. You've got not that much time to understand Spark starting with RDDs. Well, if you are focused, if you switch off all your IMs, Twitter, Facebooks, Quora, Mediums, and Instagrams, yes, you're pretty much on your way to enlightenment to understand what Spark is. But don't start with RDDs, because you are wasting your time, really. Start with data frames. And why? I'm gonna give you a few hints or prove my theory that if you start with Spark Sql, which is now the de facto the main extension of Apache Spark, you will get the best performance of your not so performant queries, because Spark Sql brings all the goodies for you without you knowing about it. Okay? That's so now. So I apologize if the slides are not very entertaining and not many cats after all. As a matter of fact, I have no cats, no pictures. I believe only there is one slide with some code. I hope I will have enough time for live coding, so we'll see all the theory live. Okay, if I'm gonna make some mistakes, they are on purpose, because we are all here to learn together, right? So if I make mistake, it's just that I assume that there are going to be some mistakes, okay? So I'm gonna build this friendly atmosphere, this culture of making mistakes to improve our understanding. So if you need me, or if you see me walking around, you can easily come and ask questions about Spark, which I'm gonna be very interested answering Yeah. Okay, so speak Spark SQL for your own good? No. Better performance? Yes. And performance, I'm performing too, right? Right now. So this is my performance. So hopefully it's gonna be better performance than what I could do without this title. So I'm an independent consultant. I'm working exclusively with Spark and SQL, Spark SQL, yeah, Spark SQL too, but Spark and Scala. All my projects are about, first, Spark, second, Scala, in this order. So order matters. I'm now partnering with Value Amplify Consulting Group with my friends, Italian friends, Giuseppe and others. So I'm working with them to bring more skills about Spark and Scala to the market. You can contact me at Jacek Laskowski or follow me on Twitter. Yeah, I hope to see more Twitter followers after this talk. I'm hoping for this. And I'm leader of 2 user group, meetups. Now it's called meetups. In my age, we used to call it user groups. Now it's meetups. So yeah, I've got 2 meetups. Remember news groups, NNTP, something like this. Oh, you are showing your age. Oh, really? So, so now Scala enthusiasts and Apache Spark meetups. Why? Because I needed you. I needed people who are like me, passionate about what I'm doing. I'm also a Java champion. After 10 years working with Java, I decided to switch to Scala because I needed to pursue my understanding of functional programming. But it was the moment where Oracle and other Java champions appointed me to this title. But it was just like kind of, it's recorded, right? So I need to be careful. Okay, so you might have heard about me by reading this book. Well, now Gitbook just flattened these statistics because there is a bug or something like this in the scores. But I reached this 4K altitude, so people found it quite interesting. That made me more into Apache Spark. So you know the trend. After 1 follower, you try to have 10, right? Then after 10, you want to have 100. When you see 300, you can't get used to having even more and more. It's like part of your life. So yes, it's part of my life. For the past 1 year, I worked with Spark exclusively every day on Saturdays. Yes, today is Saturday, right? Saturdays, Sundays, and other working days. Okay, good. That's all about me. Now let's go to explore Apache Spark. So Apache Spark, Spark 2.0. I'm so glad that I can share a lot of love and excitement about Spark 2.0 because there are a lot of hard work put into Spark 2.0. Really, I can't get even more excited about what you can find in Spark 2.0 than that, because people were working very hard on making Spark so performant, and at the same time so easy to use. So we will start with data frames. Why data frames? Because RDDs are so past century. So now we are into data frames. But for people who are working with Scala, data frames are just like Ruby and Python. They are languages, but we just pretend they are helping us to understand why we should be working with Scala. Type safety, strong type safety. The compiler is part of our delivery, right? So part of making sure that our application works properly on production. After compilation, if we compile our Spark application, we need to be sure that our application will work properly on production too. That's why we are using Scala in the first place. That's the reason why I use Scala too. So data frames. Then we switch to datasets, which are the main abstraction for Scala developers in Spark 2.0. We'll discuss a little bit about encoders, which will build what you may call schema for your data frames. And again, it might be confusing that whenever I say data frame, dataset, And you might be wondering, what's the difference between them? Well, there is not much difference, from user perspective point of view. Just think about them as one simple data abstraction. As a matter of fact, in Spark 2.0, data frames are just an instance of this data set of rows. Type instance. And then we switch to query execution, and then Catalyst Query Optimizer, which I'm exploring. I've been exploring for the past 3 or 4 weeks. Once I understood what they were telling me through this code, I said, I need to explore it even more and more, because my queries are going to be faster just by speaking Spark SQL rather than trying to be clever than what Spark developers brought to the table. And then I'll show you how to debug your query execution. So data frame. I said data frame and schema, and because data frame is all about rows, records, but they are more close to table-like structures. So whenever you work with Spark SQL, you may start with data frames because they might seem easier at first, but it's not the case. So, which you are going to see in a moment. So data frame and schema. This is the pair of the main abstractions or topics in Spark 1.6. Now, especially for me, for Scala developers, or Scala developer and other Scala developers, this is like this. So let me switch to the latest and greatest of Spark 2.1, I believe. This is the next version Spark is gonna provide you. I just built it today morning. And for the past 10 days, I couldn't show something I wanted, so I'm glad that they fixed it already. So when you start with Spark, you usually start with Spark Shell, right? Right. Why? Because it's highly interactive development and learning tool. You can teach people Spark using Spark Shell. You can learn yourself Spark. This is just the IDE you are going to use. No other tool you need to explore Spark 2.0 or other Sparks. So, it's not gonna work like this. Wait a moment, because you see it's. Wait a moment. No. Come on, don't get to not minimize. Where's this full screen? No. Did they change? Come on. Okay, so for now, I can handle it. I can handle Spark, not necessarily this terminal. Okay, so when you start with Spark, you should start with Spark Shell or PySpark. And there is also something similar for R, right? I'm not using R, so I don't know if R Shell, how do they call it? Spark R. Oh, Spark R, yeah. So look at this. How simple it is to use Spark. Well, I can see that people are doing this. SC, watch. SC, no. It's not this. SC parallelized, right? You can see it in tutorials. Stop doing it. It's so past century. You are wasting your time, you are wasting your performance, you are trying to beat something that's faster and smarter than you. Well, might be not the case, but let's challenge ourselves with this kind of thinking. So, paralyze is to paralyze you. This is this. You should not be paralyzed when you are working with Spark, right? You should be invited to more exploration. So you do something like this, Spark, dot, and then tab. Tab will help you with your exploration of what's possible with Spark. Spark is the entry point to Spark 2.0's main abstractions in Spark SQL. Okay, why Spark SQL? I'm not into SQL. Well, you might not be now into SQL, but you will in a moment. And Spark is the entry point. Start with Spark every minute, every moment you are working with Spark. So Spark dot. Okay, so then you can just range and create this 10 record data set. That's simple. I can see that people are nodding and saying, yeah, that's simple, nothing to be explained. But it's very lazily instantiated. That's the reason why it was so slow, even though my computer is pretty performant. The next time you create it, it's just like this. Okay, so what about this data set and data frames? Well, we created something that I call data set. So, okay, I'm gonna disable I'm gonna show you in a moment. What I'm gonna do, I'm now changing my log levels to be HackOn data. More better for you, for your eyes. You are not prepared to see all the gory details behind the, behind Spark execution. So I try to be nicer to you. So let me bring it back. Okay. Yeah, and after a moment, we create data set. And as you can see, it's a data set of longs. It's type safe, it's strongly typed. It's not like it was the case with data frames where you had rows which you can access columns by IDs, indexes, or names that Scala compiler couldn't check at compilation time. Now, data sets. Data sets is something you want to use. So whenever you do data set and filter, you can use filter in 4 different ways. When I worked for IBM, it was when I said that in Lotus Notes, yeah, I'm showing my age. In Lotus Notes, you could do things at least in 3 different ways. At least. Everything was available in 3 different ways. Now in Spark, you've got 4 different ways to just work with filter. And you want to see what's available? Okay, so I press tab twice, and my ideal environment, development environment, shows me there are 4 ways to waste your time, to learn Spark. So as you can see, they are depend on your skills, or they are offering you help depending on your skills. First, if you are a Java programmer, you can use it right away. The first version is for Java programmers. Second is for us, Java developers. Third, condition expression is for people who are not into Scala that much. They want to code using strings that Scala compiler can't check. So they are losing some type safety, but they are fine with it. When would you like to use this third variant? When? When you want to migrate from SQL-heavy application into Spark-based application. So if you want to move from SQL-heavy environment into Spark, you might just take strings of SQLs and make them part of your Spark SQL application. Pretty handy, right? So, and the 4th version is to show your knowledge about Spark, because you can use a column type to access columns and create something more sophisticated. Okay, so let's filter and then underscore, yeah, dataset, underscore 0, and that's it. I created yet another dataset. And be careful, it's all lazily evaluated. No execution. So you don't see anything being executed after I hit enter after this filter. It's like you worked with RDDs, if you worked with RDDs before. You are creating transformations that are being optimized. You want to see how to see these optimizations. Yeah, this is a very good moment to see it. You are very, very well prepared to see it. So if you do this, you are executing SQL query, and you can explain it to you or to yourself by doing explain. So I hit enter, and I can see physical plan. It took me half a year to understand what they were telling me with this physical plan. Well, they were telling me let me do this. They were telling me that they do my job for me. They optimized something that I explained or described by using API, Scala API. So I was having fun with Spark's Scala API, but then they did the low-level job to optimize my queries. Okay, you are not convinced that they optimized anything, right? Yes, I hope you are not. So let me do something like extended. I'm using extended even though I could use just true, just to show that this is the parameter that will tell you what I'm doing. So I want to know more about the optimizations. So there are three stages of optimization in Spark SQL. And these optimizations are very lazy. So the very first time you press enter, you start your queries, it's gonna be executed, but the next time it's done. So look at this. These are plans, logical plans that led to this physical plan. So you've got one plan, another plan. So we start with something that's called logical plan. So our queries, despite being written, regardless of the language you are using, and we've got 5 languages supported by Spark. And I hope that you don't know the 5th one. So let me start with, okay, so first is Scala. Second is Python. Oh, yeah. So Scala, Python, Java, R, and the last but not least, SQL. Okay, so some people just discover it. So there are 5 different languages. And you know what? There is a great talk, if you need this talk, it takes half an hour to watch it by people from Databricks, by one person from Databricks. And he just presented that this idea that they created a layer called Catalyst that will talk to your programs, and regardless of the API you are using, whether it's Java, Scala, Python, R, or SQL, they all go through this layer and use this Catalyst optimizations and Tungsten that are responsible for making your queries faster and faster. That's one of the many reasons why you should always be using Spark SQL. And I don't care about your language, your front-end language, whether it's Java, Scala, Python, or R, or SQL. You can just use or leverage these optimizations pretty easily because it's hidden. So as you can see here, you can see that this data set, and it took me a while to understand this. What's data set? What's data frame? Well, data sets and data frames are results of your computation or your computations, right? Right. They are just different representation of your query, right? Right. It's that simple. So we, technicians know that if there is a mapping, one-to-one mapping between with your left side computation and right-hand side computation, they are equal. They are same, right? And this is this is one of the many reasons for my excitement of working with Spark SQL or Spark 2.0 is that I understood the point why they are so picky on us developers working with Spark SQL first. Because if we are executing SQL query, we need to go through these stages to make our queries more performant. So okay, and parse logical plan. They are using for this. They are building their own data structures under the covers. But you could also do this filter by doing this. So I'm gonna change it, and you can do. So what's the SQL? So I'll do this. So what's gonna be here instead of underscore? Is it going to work? No, it's not gonna work. Why? Because this is not working SQL statement, right? It's not. You've never used underscore for your SQLs, unless you called your column underscore, which you may have not, right? So it's not gonna work. So your first question is, how can I access my columns? And now you are asking about schema. So, ladies and gentlemen, before we do this exercise, let me show you the schema. This is the schema. This is all about my data. So you can print schema, and you see, I didn't leave my environment, my working environment. I can play with the data, the petabyte of data, using this very rudimentary environment, but highly interactive. So this is my data. So what can I do now? So instead of underscore, I do ID, right? Because I'm accessing ID column. That's pretty simple. Is it gonna work with 2 equals? No, perhaps not. So let's do this like this. It's gonna work? Yes, it's gonna work. It's the same execution. It's the same physical plan that, regardless of comparing to the other Scala heavy code. Okay, you can also do something like this. So now let's use column-based API. Okay, and let me not explain, but show. So this is what you should be doing in your SQL queries using Spark and Scala. I'm pretty sure that you are wondering, why did I use only 1 tick rather than 2, right? Ah, okay. This is something I just discovered by working with Spark. In Scala, we've got type called symbol. And there could be something like this. Whatever is here is gonna be part of your symbol. Yep, it's like this. So I learned it by working with Spark. And it looks so geeky. It looks so cool. And people are always asking me, didn't you forgot about the closing tick? No, I didn't. So, and I'm proud that I can share something to these people. So this tick is similar to this. Same. This is the way to refer, to create column by using Scala's implicits that are provided by Spark. So if you wanna go, if you wanna look more geekier or more geeky, you just use this tick. But you can also go with dollars, not necessarily Canadian dollars. Not sure if they are Canadians or American dollars, but definitely they are dollars. So then there is something that people are asking me always. Why are you using this triple equal signs? It's because this one is in Scala to assign a value. It's not gonna work. Compiler will tell you it's not gonna work. Okay, so you are smart and you say, okay, perhaps this one will work. No, this one will not work either. Why? Because in Scala, two equal signs is to compare. So you will get this cryptic error message telling you that there is no method with booleans, right? Right. And you know how to fix it. The fix is to have this. And that's going to work because it's not a reserved symbol for strings or for columns. That's it. Okay. So you can just play with it. And let me see how much time do I have? 2 hours? Okay, 10 minutes. You kidding me? Okay, and I just started. Okay, so data sets. So data sets are, yeah, you should be careful asking me questions. So encoders are bits and bytes behind what you're doing, and they are responsible for creating the schema of your data. All the data that you are working with in Spark SQL is structured or semi-structured. The difference is that structured data frames are read from data stores with schema, explicit schema, while semi-structured, the schema can be inferred, can be computed. Okay, and that's pretty much all you need to know. So, query execution. query execution, you can see query execution using this explain method. So you can explain to yourself or to someone else how does this logical query plan look like for your computation. And you should work with explain early and often. They will tell you how Spark sees what you see. It looks like you should not bring all the theory you just learned in your schools to Spark, because if you are better than Spark, you might confuse Spark. It's like me, I'm from Poland, so it's like me using idioms I don't fully understand, but I hope this is the moment to use them. And then I fail. So I wanna be geeky, and I usually fail because this is not the right moment to say something that I don't fully embrace or understand. Same with Spark Sql. You should go very low level, yes, understand the tricks that the optimizations that Spark applies to your data and use them. They are the idioms that make you more proficient in using Spark Sql. Hey, is this the advice I should be giving to people new to Spark Sql, going very low level to understand how to be higher level, to be more performant, to be more optimized, or to create queries that are more optimized? Well, in some sense, yes. It's like this. If you understand how Spark talks to you, and you talk to Spark in its own language, you will beat all the performance, challenges pretty easily. So, logical query plan is the base representation of your queries, whether they are in Spark, Spark's Scala API, Python, Java, SQL, or R. It doesn't really matter. In Spark SQL, it doesn't really matter. What matters is this guy, physical execution plan. So you should explain, you should see what your query physical plan look like. It's like with databases, right? But now we are not discussing databases. We are discussing large data sets, 5 petabytes of data. So you'd rather not incur any shuffles, any bad, performance, performance degradations or something like this. Look at explain, and you will know how good you are and how good or how Spark could optimize your query. Okay, good. So let me show you something I just discovered few days ago, or maybe not discover. I heard about Catalyst, I heard about Tungsten, but it was like me repeating all something I heard from others without much understanding what I'm sharing with people. Now I think I'm closer to say I finally understood got the gist of Catalyst. Catalyst is here, is part of Spark 2.0, Spark SQL 2.0, to help you be better at your queries. So they brought all the theory from databases like PostgreSQL. They are so picky at being compliant with PostgreSQL and Hive to Spark SQL. So you don't need to use PostgreSQL and Hive. You can only work with Spark. Spark is all you need. So okay. So now I'm gonna show you few. Okay. So this is. Yeah, I've got some fixes too. So you know this. You know that I executed SQL through SQL method. That's imported in your Spark shell. You can use SQL queries. So by doing SQL select 1 + 1 + 1, you know that you could also do select 3. That's it, right? So let's see if Spark can do it for us. because we are lazy, because we didn't see it, because we copied it from one place to our Spark's code, and now we are in a hurry to execute it. Let's see if Spark can optimize it. So as you can see, I did explain through, and by doing these optimizations, Spark end up with this 3 already. It's just a simple calculation. So Spark could do it. So at least Spark can do the math. But there are other optimizations available in Spark SQL. So if you are curious what the other optimizations are, you can read my notes, or you can see the code, which I'm gonna show in a moment. So there is something like constant folding, and I hope they mean something to you. They not necessarily mean something to me, because I'm yet to explore this, but I think it's something related to database theory. They are so into databases, so they studied all the different papers. So I think that constant folding means something to you. Not much to me. Predicate pushdown, you know what it is. Predicate pushdown is when you apply your filters. So instead of you reading all the data to your memory space and then applying filters, it'd be better if you could talk to your data source and say, hey, be nice to me, this is my query, can you do filter for me? So instead of having 10 gigabytes in my memory space, I'll have half of this. So Spark can do it, especially with Parquet columnar file format. So use Parquet file format if you wanna go pro, if you wanna be pro, yeah, or if you wanna go faster. JSONs, CSVs, XMLs are, just leave them behind, or know that you are losing some performance because of the file format. Nullability, so if you compare with nulls, you are just saying that you are comparing with null, so you need nothing, or just columns with nulls. And there are other and this whole stage code generation, whole stage code gen, this is pretty cool. You can see it in a moment. You will see it, and you can see it by debugging. So, and there is something like Spark Optimizer. These are two. Yes, this is something I just explored 2 or 3 days ago. So pardon me if I'm telling you something that it's not really true. But as you can see, when I do Spark range. So I'll see here. So when you do Spark range here, 10, you are creating 10 records in your data set, right? You could go with 10 petabyte of data, but let's make it simple. I just filtered all the even numbers, and then I just filtered, I needed just 0, right? So you know that you can optimize this to look for just 0, right? You can do it. It's so visible. It's here. But you need to be careful, because if I made this code a little bit more convoluted, you might not have seen it, right? It might be buried in my code. And if you couldn't make it simple, perhaps Spark will. But there are moments where you could confuse Spark too. So as you can see, by doing this optimized plan on my query execution, which is part of explain, so you will see it, you can see that there is one typed filter with function, and this function has all you queried for inside. So you don't see the code here because you don't want to see it. But if you insist on seeing the code that's being executed inside, well, let's do this. So by doing this, 5 minutes left. Okay, so data set. So I created my data set. It was pretty quick, right? So I can do data set, and I can explain, and I can do true or without this. I can see that I've got filter and range. If you are picky about what's on the screen, you may have noticed that there is this star, right? What's the star before range? What's so special about this? Why range is star? Well, or start. It's because it's part, my understanding is that it's part of something that was generated, and it's highly optimized in something that's called whole stage code gen. So Spark created program for you written in Java that's gonna be executed whenever you are calling this query, this simple query. It's very simple, but Spark applies all these optimizations every moment you hit enter and you say show. Whenever you do show, these optimizations are applied, and you should be happy with the performance. So how can we debug what was generated for my query? Well, let me switch to this. So debugging query execution, this is the last slide. So by using debug package, you can use two methods that will show you low-level details about what's coming when you execute your query. So when you do import, just debug, you will get all the benefits of this package. So let's do this. So by doing this, so I'm gonna, okay. By doing this, you are bringing something very neat, very useful to your toolbox, Spark developer's toolbox. So let's see what was generated, what was created under the covers for your simple data sets. For this, it was pretty basic because it's just debug. You are going deeper and deeper into Spark optimizations, but not that deep. If you want to go pro, and I'm pretty sure you want to be pro, so Debug Code Gen. So this is the method that will tell you what the code looks like for your query. And then you can read it. And you know what? I just learned 2 days ago, there is some technique called volcano something. It's used in how is it pronounced? Volcano? Or this is the technique in databases to generate code for your queries. So they use it. So there is this pattern, and they just discovered that this pattern is not very efficient. They can do better by doing what your friend who started with Scala would do. Very basic query that can be optimized by processor, by your architecture, by your machines, because you are not very clever. You're just talking to these machines in a way they can understand and optimize for you. And as you can see, this is the entire code behind your query. And then you can make it better if you know how to do it, but this is the entire code behind this simple data set filter. Yeah. Okay, and that's pretty much all I've got. I could talk about it, but as you can see, there are a lot of things to cover, and I didn't know, how much you know about Spark. I hope you like it. I like this information about the differences between data frames and data sets. Whenever someone asks you what's the difference between RDDs, data frames, and data sets, the answer is very simple. First, what's the difference between RDDs and the rest? Well, they don't have these optimizations. They are very basic ingredients of your Spark's code. That's it. If you, as I said, if you want to go pro, have you seen this movie? Okay, so I'm not going to say it. So this is part of this exercise. So data frames, the difference between RDDs and data frames, this is Quentin Tarantino's movie. So this data frame, the difference between data frames and RDDs is that data frames come with these optimizations. Well, you wanted to see these optimizations. They are all optimizations available in Catalyst. So look at this. There is batch for finish analysis, eliminate subquery aliases, blah, blah, blah. There are all optimizations coded in Spark. I'm showing you the source code of Spark just to, impress you, not by my skills, but what Spark SQL brings for you. And it's free of charge. So don't try to be too clever, because you will beat these optimizations, and then you will lose performance unless you are very good at optimizing Spark queries. So data frames come with optimizations. Catalyst and dataset and Tungsten. What's the difference then between data frames and datasets? Well, datasets are strongly typed Scala types for you, so Scala compiler can review your code and say something about the data you are working with through schema or through encoders. So since we are, so into Spark's type programming, Scala type programming, we care about them. Query execution, okay, so you can see, you can use explain right away without importing anything. Then if you import this debug package, you will get 2 additional methods for your queries, debug and debug code gen. If you embrace what Spark brings to your queries, I'm pretty sure you can beat any performance competitions using Spark and leveraging what Spark brings to the table. That's all from me. Thank you, and have fun being part of this great initiative. Thank you.
Thank you so much, Jacek.